Alright guys, let's talk about evaluating some more integrals. Alright, specifically complicated ones that look like this, where we have something times something. What we need to be careful about is, unlike where we had something like this, where we had the integral of f of x plus h of x dx, we could evaluate this integral, then this integral separately, and then add them together. We can't do that with multiplication. Instead, we need to use a technique called substitution. Okay, so I'm going to do a few examples here. Let me just do this first one out so you can see where we're going, and then I'll do a little bit more preview talk in the next two examples. Okay, so this is how I'm going to do this. It's called substitution. So I'm going to set u equal to something. In this case, I'm going to choose x cubed. I'll explain why I'm choosing that in a second. Okay, so u is x cubed. So my integral is now 3x squared sine u dx. Okay, so my goal here is, in taking this integral, I want to take all this complicated x stuff and morph it down into things that just have u in it. Okay, so dx, that's no good. I want to take an integral with respect to u. So this is how I get dx into du. I take a derivative of this. So du divided by dx, so du dx is 3x squared. So that way, when I multiply both sides by dx, I have du equals 3x squared dx. Aha! 3x squared dx, 3x squared dx. So I'm going to do substitution. So we have sine u, and then these things that are underlined I replace with du. Alright, so now I just have to take the integral of sine u du. Awesome. So the integral of sine, maybe you remember, or the antiderivative of sine is negative cosine u, and then since it's an indefinite integral, I need to do plus c. Alright, so we're looking really good. The only thing is we're almost done, not completely done, because our original had x in it, no u's, so I got to get x's back in. So negative cosine x cubed plus c. And if we ever want to double check our work to see that we took the antiderivative correctly, let's look at our answer and let's take the derivative. Okay, so now let's take the derivative of negative cosine x cubed plus c. All right, so the derivative of negative cosine is going to be positive sine x cubed, but then we got chain rule, right? So this is sine of some junk. So sine of some junk, I got to multiply by the derivative of that junk, 3x squared, and then the derivative of constant is 0. So I have sine of 3x cubed times 3x squared. Perfect, right? Okay, let's do another example. All right, so remember in the last slide when I chose something to be u, then when I took the derivative, the other x's showed up. So in this case, what I'm going to do is say u is x squared plus 9. This way, when I take a derivative, I'm going to be able to get rid of this single x, x to the first exponent. So when I use something, I want to try to use something that is 1 power greater than the other stuff. That way, when I take the derivative, the other stuff will disappear. Let me work out the rest of this example. Okay, so du equals 2x dx. Okay, so now my derivative is going to look like this. X times u to the 5th dx. All right, and so x dx is the stuff I want to get rid of, x dx. So I got to make x dx here, so I'm going to divide both sides by 2. So du over 2 equals x dx. All right, so now I can do my substitution. So I'm going to have du over 2, so that's 1/2 du, right? So 1/2, then I'm going to have a du, but I still have this u to the 5th. All right, so there's my new integral that I need to evaluate. So I'm going to go like this. I'm going to add 1 to the exponent, so it's going to be u to the 6th. But then I got to divide by that new exponent. So 1/6, but I also have a 1/12 or a 1/2, so it's going to be 1/12. And then since it's an indefinite integral, I need to do plus c. Okay, and we're almost done. We just need to plug our u back in. So it's going to be 1/12 x squared plus 9 to the 6th plus c. And once again, if we want to take a derivative, we can. So 6 comes down here, so it's going to be 1/2 x squared plus 9, but then we got to chain rule it, 2x. And notice that's the same, oops, forgot to the fit there. And that's the same thing that we have there, right? Because the 2 and the 1/2 go away. All right, so good to go on example number 2. Let's go to example number 3 and the final example. All right, here we go. What do you think we're going to use? If you guessed x cubed plus 1, you're in good shape. Because this way, when we take the derivative, we're going to get an x squared term, which will help us get rid of that guy. All right, so 3x squared is our derivative. So we want to try to substitute out an x squared dx. Okay, so let's bring this dx over here. So we're going to have du over 3 equals x squared dx. All right, so my new integral is going to look like this. This is going to be the square root of u, and then x squared dx becomes du over 3. Okay, heads up here. Something we need to be careful about. 0 and 2 are values of x. They are not values of u. Okay, they are values of x. The writer of this problem has no clue what u is. You are making up u. Okay, so 0 and 2 are not values for u. They are values of x. All right, so at this point you have two options. One option is you can change the limits, and I think that's the way I'm going to go. Or you can evaluate the antiderivative, then plug x back in and use the same limits. Maybe I'll do it both ways to show you. Okay, first off, I'm going to change the limits. So remember, 0 and 2 are limits on x. Okay, so to figure out the limits of u, let's plug them in. So let's plug in 0 here. All right, so u is going to go from 1, and now let's plug in 2. 2 cubed is 8, 8 plus 1 is 9. So it's going to go from 1 to 9. All right, so now let's evaluate this new integral with new limits. Okay, so this is u to the 1/2, so it's going to be u to the 3 over 2. But now I got to divide by that new exponent, so that's 2/3, because multiply by the reciprocal, and then 1/3 because this is already out front. And I don't have to worry about the plus c thing because we have a definite integral. So I got to evaluate from 1 to 9. Okay, so I got 2/9, and then I got to multiply 9 to the 3 over 2 minus 1 to the 3 over 2. Okay, so 2/9, 9 to the 3 over 2 is the same thing as the square root of 9 to the 3rd, and then hopefully you can see that's just 1. Okay, so the square root of 9 is 3, 3 to the 3rd is 27, 27 minus 1 is 26, so we're going to have 2/9 of 26. Let's see, does anything simplify there? Do any 3's go into 26? I don't think so. So I think we're going to have 52 over 9 is our final answer for that one. Okay, so quick review. When there is multiplication, you cannot do the integral of this part, then the integral of this part. Instead, you need to do u substitution. Choosing what u is the hardest part. Okay, you want to choose something that when we take the derivative of it will help us get rid of the rest. Okay, if you have questions, please write them down, bring them to class. Talk to you later.